let's say you got a question like that. That's how to differentiate using a product rule. So this is like a classic case of double product rule. In double product rule, you have to use a product rule twice. So what you need to do is you will actually come up with one u and one v. To make life easy, I can rearrange that one and I can say it's up to you how you want to do it, but it's going to be both ways will lead to the same answer. So let's see if I write x to the power of 1.5, I can write 1.5, yeah, because 3 over 2 is 1.5. E to the minus 4x, I can write that way, dot 7 cos 2x, yeah. So I just kind of rearrange the things. I put the 7 next to the cos 2x because there's a lot of other things there, so that will, I thought, get rid of the 7 and put the 7 there. Now then I'm just going to take that one as a u and that one as a v. So my u is x 1.5 e to the power minus 4x. And my v is 7 cos 2x. Now, if I want to find dv over dx, the 7 is already there. Cos 2x becomes a minus sine 2x. So I got minus sine 2x. And then there's a 2 will appear there as well. Yeah, because of that one. And then the 7 is already there. So 7 times 2 is going to be 14. And I'm writing minus 14. The reason I'm writing minus 14 is because if you see there is a negative in front of the sign. So that was straightforward. Now I need to tackle the other one, this one. Now to find that one, I will go to the next page and we will just do that one over there. But I'm not going to call them u anymore. So I'm just going to treat that as a separate entity. So let's go to the next page. So let's say I need to differentiate this bit. To differentiate this bit, I'm just going to call that one this side as u and this side as v. Yeah, again. But that will be different than the other u and the v. So I'm going to call that one u1 and the v1. So that will become a u1 x to the power 1.5, which is 3 over 2. Yeah. And v1 e to the power minus 4x. You know, if I want to do dv1 over dx, that's going to be e to the minus 4x, and the minus 4 comes in the front as well. That's done. That is x to the power 1.5. So du1 over dx. 1.5 comes out, reduce the power by 1. So 1.5, which is 3 over 2, comes out. Reduce the power by 1. So when I reduce the power by 1, 1.5 minus 1 is 0.5. That's that one. So if I apply the product rule here, that's why I said double product rule. If I apply the product rule here in this one, I need to do that times that and that times that. So let's do that one on the next page. Because the product rule is u d over dx of the u1 v1 is equal to u1 dv1 over dx plus a v1 du1 over dx. Now let's put the values. What was the value of the u1? X 1.5. What's the value of this one? Minus 4 e to the power 4 minus 4x. plus v1 was e to the power minus 4x, and differential of that one was 1.5 x to the power of 0.5. I got these things. I can rearrange it. Minus 4x, I can write, instead of 1.5, I can write 3/2, but 1.5 is easier to write for me. And then e to the power of minus 4x. Plus, this, we don't write that way, so I'm going to write 1.5 first. X 0.5. E to the power minus 4x. Done. Now I got this bit. And I also got that bit as well. Yeah. So I differentiated that one and I differentiated that one. Now I need to go back to the basic. This was a second product rule. The first product rule was, I need to change color. It's UV equals to U dV over dx plus V and du over dx. What was U? The real U. The real U was this one. So I'm just going to copy paste that thing. X 1.5. E to the minus 4x. And differential of dV over dx, which I will get from here. Minus 4 e to the minus 4x. Now I will write the other one in a while, but let's solve this one first. Minus 4 I write in the front. X 1.5 I write in the front. This is e to the minus 4x, and then there's another e to the minus 4x. When you got x times x, or let's say x is not a good example, let's say y times y, you write y square. You square the y. If that was a y square, you add the powers. So that becomes a y 4. If there was an x here and the x here, that becomes a y 4x. You just add the bit that on the top, law of indices. Yeah. So I'm just going to use the same technique. That will become a e to the power of minus 4x minus 8x plus. I don't know about that one yet, so let's go back. What was v? Go back to the first one. The v was e to the minus 4x, so write it down. E to the power minus 4x. Done. Now, then after that one, du over dx. Du over dx, I need to do this thing. This is a u. So du over dx, which I couldn't fit here. So I did that one here. So that was the answer for the du over dx, because this is actually a u. So I'm just going to copy paste that thing over there. So let me just copy this thing, and I'm just going to paste that one here in this bracket.
You've got the v wrong. The original v was 7 cos 2x. That's v1.
That's v1. Thank you. The original v was 7 cos 2x. Yes, thank you. Yes. So did I got the v1 wrong as well? Yes, then I got this one wrong as well, isn't it? Yes, so I got this one wrong as well. Thank you. This is not the original v. That was a v1. Sorry. This is the original v, not the v1. Okay, so original v was 7 cos 2x, and minus 14 sine 2x is the dv over dx. So that was, I need to replace this thing by and it will affect that bit as well. Sorry, that's my fault. Well, the good thing is I'm not gonna lose any more. Okay, minus 14 sine 2x. So that will become a minus 14 sine 2x. Yeah, which will give me, if I simplify, that will give me minus 14 x to the power 1.5 e to the power minus 4x, that's e, and divide that one again, and then a sine 2x plus v here is, that v is wrong, v here is 7 cos 2x. So let me just copy that one, much easier. 7 cos 2x, that's not the v, that's the v1, which is so we got the 7 cos 2x, and this is, I believe, is right. Now you're going to multiply that du over dx. I'm just going to check that one. Yeah, that's it. So I'm just going to put that thing there as well. Now multiply the 7 all the way inside. So that 7 times minus 4, that will disappear. 7 times minus 4 is minus 28. Minus 28 x to the power of 1.5 e to the power of minus 4x dot cos 2x plus, because that's plus and that's plus, that will be another plus, so I don't have enough space, so I'm going to write here 7 times 1.5 is 14 minus 3.5, so that's going to be 11.5, and then I got x to the power of 0.5, 10.5. There is 10. What are you guys talking about? 10. 0.5. Sorry, my maths is not very good. Oh, sorry. 1 point. That's that one. And then I got e to the minus 4x dot cos 2x. I can see if I can simplify further if they are like terms, but no, this is x 1.5, this is x 1.5, so yeah, they looks like the right term, but here this is a sine 2x and this is a cos 2x. Can't do anything. I cannot do anything, but what I can do is I can do just one more step to simplify it further. So just to avoid me writing again, I just copy paste and I do that one here, and then we just see what's common. I can take there is a e to the minus 4x here, and e to the minus 4x here, and e to the minus 4x here, and there is also x, the minimum x to the power. Okay, so let me take this e to the minus 4x out. So e to the minus 4x out, e to the minus 4x out, and you are going to left with minus 14. Yep, I'm just leaving a little bit space. I'll tell you in a minute why. Sine 2x minus 28 cos 2x plus 10.5. Here's x 0.5 common as well, which will give me x1 and x1 and no x here. So that will be your